and saying welcome back to our Everyone Can Contribute Cafe meetup. And this time or this month, we thought about looking into Chainguard Enforce, which we saw, I think, 2 weeks ago or somewhere around being announced on Twitter. And I was clicking around on the product website. And I was like, contact the fine folks at Chainguard for a beta or for a demo. And I was like, maybe I can ask them on Twitter and they might join us for showing what they're building. And I'm super happy that Carlos joined today. And yeah, I would just say, maybe do a short introduction and then introduce us into Chainguard and Enforce and software supply chain security.
Okay, thanks, Michael. My name is Carlos. I work for Chainguard for about 2 or 3 months now. Before that, I was working for a company called Mattermost, which is partnership with GitLab. That's it's a nice solution for collaboration too. At Chainguard, I work almost in all the parts of the company right now, from the bottom to top. And we are like building for quite some time the Enforce app for the like to fix some supply chain issues we have. In my spare time, I also contribute to Kubernetes Upstream, which I'm part of the SIG Release as tech lead there, and also in the cluster lifecycle SIG as well, in the cluster API ecosystem. And also for other open source projects like Falco, Helm, and others. I think I can share my screen, right? Yeah. I'm going to share a presentation that just... the idea of this talk is just to be, I'm going to speak a little bit and then we're going to do like a demo. Like we're going to be like not a complex demo, but like just a simple one to explain how things works. And then later on, if like people can ask questions and like I would say for more in-depth demo, we can maybe schedule one-on-ones to do that.
Sounds good.
I hope you can see the screen.
Yes.
Okay, then let's start. What's the Chainguard? It's a company, and then we have a software, like a system, an application, or whatever you want to call that. That we call it the Enforce. But before we jump on that, like, let's see what's the problem of the supply chain security we have. That's become like a hype. Everybody's talking about that, right? And it becomes like very like in the news and all the stuff like last year with some attacks at I forgot the name of the company. SolarWinds, yeah. And that was like a really bad thing that happens. And for some numbers we saw like there is a lot of increasing in attacks over the last year. And there is a lot of like, as we can see from Gartner, there's like some experiencing like 3x increasing like since 2001. Like there's a lot of attacks on that, like people saw that can somehow attack. And if you think like there's a lot of projects out there and they are using like known like publishing sometimes secrets, publishing sometimes weekly like weak pipelines that the people can just submit a pull request and maybe change those things. And to fix that, like there's no single fix, so we need to fix like across the pipeline. And we have like some frameworks to help on that like as well. Like we have the SALSA one, SLSA, we call it SALSA, and there's this NIST SSDF as well that helps a little bit as well. Then we came with the Chainguard. Enforce is like a supply chain security solution for cloud native workloads, mainly like namely if you run Kubernetes or container applications, we can help on that, like to help your environment in your Kubernetes. The idea is you have like things coming from the development team for like, for example, from NPM, from GitHub, from GitLab, from any other sources, and that gonna like we have like a policy that we can check and validate and generate like a database with all the assets you have running in your cluster, and then you generate some policies for you, like for your company, for if you have like a set of clusters. I would say you have one cluster for the team finance, another for the marketing, and so on, that we can have different policies for different teams. We can have like one high level policy for the entire company, and then it enforce like can be used also to generate bones, bill of materials, can like continue monitoring the containers for CVEs and all this stuff, and this alerts the who is using the tool, and also generate like a set of insights that you can see the inventory in real time. Okay, here. The idea of the Chainguard Enforce is like we draft the policy, like our organizational policy, like for example, we should only deploy signed images, and that's gonna be like we can define from where, like which registry, from which signer, from which issue, you can define those things, and that we can observe, like you can monitor in the compliance of those policies. And then, like for example, like there is no image signed, it's gonna appear in the report. And then let's, for example, you improve the automation and compliance. For example, you add the signing step on your CI/CD pipeline, and then like in the end, you can like enable the enforcement. That means if your image is not signed by the specific issuer, for example, it's not going to be deployed in your cluster. And then this you can have like a cycle of like feedback loop as well. For example, you can define other policies as well, like my system needs to build meet SASA level 3, it needs to be reviewed by 2 persons. There's a lot of things we like, you can draft a policy to monitor and have some audit on that. Again, like some other types of policies, I'm going to show the demo one type of policy, but we can have others. Like for example, the image we are deploying have S-bones attached to the image that we can filter out, or we can validate. Like for example, if there is a key, multi-hardware keys for approval before deploying the containers, like people should be going and approve by using the hardware key. This, if you think, is more for like restricted environments, like maybe for Department of Defense or others, but it's a nice thing to have as well. For example, you can have like approve the dependencies that can be allowed to be deployed, base images from your container. If that base image differ from the base image that is in the policy, it's not going to deploy. Only, for example, we only approve, let's say, for example, an Alpine version 1.2.3. But if you get Alpine latest, it's going to block it, and for example, and deny you to build and deploy things. We also can like use KMS integrations with the, for example, AWS KMS or others, and we can have like custom integrations as well. Okay, let me stop sharing here, and I think, I don't know if it's going to be a lot of sharing to not share wrong things here. First, I'm going to share the GitLab repository for the demo we have. I'm going to just quickly show this is the application we're going to build. It's very simple. There's nothing like fancy. It's just like a simple web server listening on one specific port that will reply things, and that's it. And here we have a GitLab CI pipeline. I hope everybody can see, right?
Yeah.
Okay. For now, like to make it easier for us to not writing everything, I comment out the signing part, but we have here for now 2 stages, the build one and the release one. The build one is building that application, like that code we saw before, using KO for building the image container, and it also pushes to the GCR for, in our case, we are pushing everything to Google Cloud Project we have set up. And this builds the image, and then in the deploy part, it's gonna get that image we just built it and deploy in our running cluster, for example. Imagine this is your development work, and then every time like we open a merge request, people approve, and we merge that merge request. We're going to trigger this pipeline and going to deploy in our, let's say, test environment, for example, or even deploy on production. I already have this. Let's reshare here. This is already deployed. Let's take a look here. This terminal is good for everybody to see.
Yeah, thanks.
Yeah. Okay, then let's take a look on this image. The image is this one here. Let me clean the screen. Let's do export. I'm gonna just export this cosign experimental because we are signing the images using the keyless approach from cosign. And I'm gonna use cosign verify this image that we have in our cluster right now. And running that, there is no matching signatures. That means we don't have any signatures. Like when we built that image, we didn't sign that. Okay, now the idea is we're gonna deploy our Enforce agent on this cluster here, which we don't have anything right now. We just have our demo app, and in this case also we have our GitLab runner for that we only use that runner to run for that specific pipeline, and there are other applications for the system. Let's use the Chainguard CTL or Chainguard kernel, and we have a brief discussion about the kubectl, kubekernel. Yeah, it's the same here. Like I call it chainctl, and I'm gonna log in first. Okay, and I'm gonna list the policies we already have. By default, we have a default policy from the Enforce, which means, let me get my script here, which means this is the policy is like our Chainguard image that we use is signed by us, then it's gonna check for those registry, and you're gonna check for this authority using this keyless pointing to full.sigstore.dev.
One question.
Yes.
Is the information from the policy coming from the Kubernetes cluster or from your account? Where is the policy stored?
This, when I did the chainctl auth login,
yeah,
I connect to the Enforce SaaS, the Enforce,
okay,
our SaaS service.
Got it.
And this is the default policy that we're gonna be available for all the clusters that gonna get the agent installed.
Okay, got it. Thank you.
Okay, no problem. Now let's take a look on let's say we saw before, like I spoke like that we can create custom policies, right? Then the idea, okay, let's just the idea, let's create this demo app policy here that's gonna listen images from the Chainguard demo registry, and also from Docker.io and from GCR.io. The other part here is we're gonna add this authority here. The key less should be like should point you to the Fusio. The identities should be the issuer. In this case, should be accounts.google.com, and the subject should be the service account we have defined. If we use another subject, for example, to sign the images, the policy is going to complain, and then we can check it out, and then maybe if we start enforcing the policies, that's going to be rejected. That means like we only accept the image that comes from those specific parts here. Okay. Now let me export one variable for the group. And I'm going to create that policy we saw. And if I do again chainctl policies ls, we now see two policies. The one first is the one, the default one, and the second one is the one that we just created. Now, the next step is we're going to install the agent. And the agent here is different. It's a little bit different from the other agents we saw, like, for example, other agents that install and collect metrics and send to the system. Our agent is very like lightweight, and usually like we are like defining, but the request is that the limits for CPU and memory for us, we define is 1 CPU and 1 gig of memory maximum. And the request is like a 50 is very timed, like for requesting. It's not consuming a lot of things. Of course, if you like have like a huge cluster with like a dozen thousands of policies, it might consume a lot of things. But the idea we are working is like to consuming less and less resources from the cluster that you are installing. That means you're not gonna see much consumption from this agent. If now let's take a look on the clusters that we have. There's a lot of clusters here, and in our case, is this one here. That is already collected metrics. We can see the version of the Kubernetes, which is the version of our agent running, and we can see other informations as well. Now we're gonna take a look on and let's see if you can increase a little bit this. On the policies, like it start collecting the policy. It's not good, right?
For me, it's right okay to see it.
Yeah, let's see if this helps a little bit. Yeah, it's because the ladder is too big. And let's see if you can see some stuff here. For example, this is, I'm gonna highlight here. This is we applied the policy that only accepts the coming from image signed from the Chainguard demo registry and coming from those specific authorities. And this is the image we saw before is not signed, right? And the demo policy, it's failing here. As we can see here, this is failing. But if we take a look, it is still running because we didn't enforce like that policy. We are just observing right now the policy. Let's take a look again here. And for example, the default policy that's coming from Enforce allows the registry Chainguard POC and the Chainguard staging that is signed. And then we can see that policy is passing here because it's signed. Okay, now let's take a look on the.
Can I ask one more question?
Yes.
So in the agent is now running inside the cluster.
Yeah, the agent is running in the cluster here. I'm gonna.
It's using normal validation mutation webhooks or to enforce.
Yes. Yeah, but okay. Not in the cluster, outside the cluster.
Ah, it's outside the cluster.
Yeah.
Oh, okay.
This is the agent we are running here, okay. And they collect some metrics and stuff, and then you can have all the information.
Well, and when you would enforce the policy, how would that work? Over mutation webhooks, or?
Yeah. No, it's a validation webhook, I guess.
Okay.
Yeah.
Yeah, I mean over the webhooks, if it's validation mutation. So,
yeah.
Okay.
The mutation gonna change things, right? We just gonna try to block.
Okay, got it.
Now I'm gonna. Okay, let's take a look here. Let's do. I'm gonna quickly change. Just give me a second. Let's uncomment the pipeline. Enable, just committing here, sign. Okay, let me show again. Here. I hope you can see the pipeline.
Yeah.
Okay.
Yeah, we see currently your full screen, I think.
Okay, let's take a look again here. Oh, it's better. Yeah, it's better. Okay, now here it's building the new image. Let's show quickly here. Was comment out the signing part. Now I just remove the comments, and the pipeline now have 3 stages: the build, sign, and release. It takes a little bit of time, and glad that GitLab have the dependency proxy that we don't need, like, because we are pushing this image from Docker, the Google Cloud SDK. We are gonna passing by the dependency proxy, then the GitLab proxies the image for us for quite some time. That's really,
that's nice.
That's really handy that you avoid the rate limit Docker Hub if you don't want to.
Hello.
Hello.
Yeah, hi. While this is going, it's a good demo. Great. Thank you very much for conducting this. I just typed a question in the chat. So you kindly can answer that.
Can you verbalize your question?
Yeah, okay. So I have seen other security tools like Prisma Cloud, which is previously was Twistlock, of course, for the cloud native applications. Now this is the tool for supply chain, which is almost the same, applying policies, various policies to the Kubernetes environment, right? So how and why this is, we call like specially for supply chain, how it is kind of, because we are conducting here for supply chain, and that's why it is for, and that's my understanding. I may be wrong.
The idea here is like we're gonna like you need to do your homework before, right? We need to start like signing the images, generating SBOONs, and applying the frameworks, like for example Salsa, and then the Enforce is gonna like start helping you. Like if you don't have anything on that, they're gonna start helping you to provide some insights and information that you can build up and be compliant with the policies you will apply it. The idea, like in this demo, I'm gonna be very simple, like just gonna talk about the signing part, but also Enforce can like look on the bill of materials of your container and generate a report on that and see, for example, you are using a base image to build your container that contains, let's say, 4 high or critical CVEs that are gonna alert you, and then you can log it. That's some problem here.
I can understand that. In fact, to go to your slides, I just saw this second slide. I believe you pointed out all the features. So like that's, with due respect, I'm not complaining or I'm not commenting. I really want to understand that how it is different, because every tools today, cloud native security tools, they pretty much do the same, like all the features what users showed. I just want to understand how do you compare yourself with all those tools, and what extra you're doing for this cloud native applications for this supply chain applications or data. How is different and why it is special? That's honest. That's my honest ask. Actually, it is not to actually really asking a question or challenging you. Not
okay. I read the chat. Like a Prisma Cloud, I have like I never heard that before, to be honest with you, and I cannot comment on that right now.
That's Palo Alto. That's from Palo Alto. It is a pretty old. I'm surprised a little bit that you have not heard of it, but
yeah, I'm not familiar with that tool. But for example, if you take a look on the other tools, like for example, Kyverno or OAPA or Gatekeeper, that have policies, you can apply policies and all this stuff, that can work together with Enforce as well. That you can use in combination as like for complementary things. Our focus here is more on the supply chain things. Okay. Like for example, when you build on a container, we're gonna check what's the dependencies on that your application, the dependencies in the container, and show out all this stuff. Okay. And then we can enforce on things. For example, if we are using a specific dependency, you can allow only that specific dependency to be deployed in your cluster, for example.
Okay. I just gave the link. So.
Okay, I'm going to take a look later.
Okay.
I think going back, okay, everything was deployed, and then if we take a look here, we signed the container as well, and this is using the GitLab OIDC token, but we cannot use that one to sign the containers right now because GitLab doesn't have some specific fields that the cosign tool needs to sign. That's but we are using that token to sign to get the credentials and stuff for the Google Cloud. Okay, let me stop sharing and sharing the terminal again. I guess let's take a look here. It's running. Let's describe this again. Let me get the image. And let's try again to verify. Now, I hope this image is signed. Yeah, the image is signed now. And if we see here, we have the issuer from accounts Google and the subject that is the service account we defined earlier. And this is defined in the pipeline as well. Okay, now let's take a look again on the cluster records, and let's okay, I need to, the cluster checks every, I think, 30 minutes for now in our demo environment. I need to accelerate a little bit. Let me run. Okay. Let me run again. Yeah, now we have here that we have the demo policy, and now it's passing, and using this image here that is passing now, which is signed. Just to confirm, is the same image we just verify, but we can do it again. Yeah, and it's the same. Okay, now we are in the stage that we are just like monitoring, right? We are just seeing if the things we define in the policy is like matching or passing or failing. And in this case, now it's passing. Now the next step for us is like, we are good with this policy, and then now we are gonna do the enforce on that. Like we're gonna enable, we're gonna say like now we're gonna apply this label like to enforce things on the namespace default, which is the one we are running our example app. And let's say, for example, we want to deploy, like I'm a developer, I'm like need to deploy quickly a container to try out whatever I need to try out, and that container is not signed. And I try to run the, let's say, the image Ubuntu. That's the simple stuff like the admission. Now it's going to that policy, checking this image is not signed, that's fail, but is not coming from also from that specific authorities, and then it blocks. And we cannot deploy that, like it's gonna like be blocking. For example, now I want to deploy, for example, the distro-less BUSY box is signed, but different authorities. Like remember, like when we create the demo policy, we set some specific issue and subject. And this, for this image here, they have a different issue and a different subject. By the policy, if we deploy in this namespace, also it should block as well. And it complains here, there's no matching signatures and non-matched identities. That means now we like complete the cycle we saw in the presentation, that we like define the policy, we observe, we act on that, like to improve our pipeline, in our case adding the signing, and then like we are good to like start enforcing things, and then stopping like deploying an image that is not signed. In this case, with different, like with we cannot deploy on this namespace image that's not signed with the specific keys. And this is a simple one, like for example, like as I mentioned and you saw in the presentation, we can enforce policies that if the bill of material contain a specific dependency that is under a version 1.2.3, for example, we can start blocking those things. I think that tool like that you mentioned, that doesn't take a look on the bill of materials in depth, but the Enforce can take like in-depth analysis on the container based on the policies, and then we can take a look on the things we have. Now, let's stop sharing. Let me go back here. 1 second.
Thanks for the great demo. I've done some live tweeting, so you're being tagged.
Okay,
it was really great to follow. Thanks for that.
Try to be more slow on the demos. Okay, let me quick share here to finish. As we saw before, like we can have other types of policy, and the Enforce can start acting and monitoring those things. For example, we can distribute the policies for the team A, and then we can go distributing the policies like from the top to bottom, or have a specific policy for the data science on team 1, 2, 3. And then in the end, we can summarize everything if all your clusters is compatible, like matching the policies. And we can have multiple types of deployment. We can have one managed by us. And also, if you want to manage by yourself, you can deploy the Chainguard services in your cluster as well. And this is just like going back, like we saw in the beginning. We're gonna announce, I think soon, we are working some base images as well that we can use, and then gonna be very easily to use those images that we are aiming to not have any CVEs, and if people find CVEs, we're gonna fix more fast on those things. And that's it for today. If you have any questions, if you want to see any other thing here, or as we saw in the past, if you have ideas with type of policy, I'm gonna collect your feedback and pass through, and we can maybe see things in the future.
I had a bit of a use case question, and thanks, Carlos. Really nice to meet you. Obviously, I'm a bit of a fan. I bumped into the Chainguard team on day 1 last year at KubeCon, and kind of stayed close from there. So I'll give you a customer use case, and you tell me where Chainguard fits, because my colleague Ponch, she was asking some questions with regards to commercial viability and just understanding where the market is. So my question is, I had a customer maybe 2 years ago that effectively was compromised by a software supply chain attack. One of their Java developers brought in a malicious package from Maven, and the application, the component went into the pipeline. It was a Jenkins pipeline running in AWS. That component ended up including a piece of malware for cryptojacking. From there, the cryptojacking malware consumed compute resources in Amazon, which then they found out about it through a bill, right? Like they got a bill in the mail that said, this is $30,000. And they started asking questions. Why did our bill increase this much? So to the question of, obviously a CI/CD and DevSecOps pipeline includes a lot of phases, but I think Ponch was trying to understand how does, or if does Chainguard address that type of use case? How does it kind of ensure that the package is signed and that there's kind of a block in terms of that component or that package from a Kubernetes perspective?
Yeah, good question. I want to try to answer, for example, as we saw in the demo, you can we are in this demo, and the Enforce is only one part of the chain, right? And if you already built your application, and let's say, as you mentioned, was in a Jenkins pipeline, that somehow the malicious code went there and then just propagating your container maybe, or in your package, Java package. When you deploy that in the environment, we're gonna like, you can have some policies that say, that's maybe you can define, okay, I have my application, those are the dependencies I accept, right? And then you can create a policy for that and say, okay, then I'm deploying this container 1, 2, 3, and I'm gonna check the bill of materials of this container. And then if there is something that is not matching that against my policy, the first policy can be like, it's signed, yeah, it's signed, pass. The second policy can be, does the base image match with the base image I'm expecting? Like can be in like specific digest, like, right? Or if the base image is signed as well, like we can take a look on that. And the next is policy, we can say, okay, all those things passed, now we're gonna take a look on the dependencies. Those dependencies matching the versions I'm waiting for, they match the hashes I'm waiting for. Okay, there's a new dependency here that is not matching my policy. Maybe it's this hijacking stuff. Okay, block and do not deploy those things, and they're gonna block, and you're gonna receive an alert, and then you can act on that. They're gonna block, but we can like write some policies, and like we can have a database that like we have already have an no like packages or dependencies that as compromised. Let's say if you download a Maven package ABC on version 1.2.3, and that is have a well-known CVE or it's compromised, we're gonna have in our database, and then it can act as you don't know. It can be a default policy for the cluster itself, and then it's gonna block.
Hey, I actually, my question was a little different. My question was not related to technology, but the use cases. Does this tool like have any pre-knowledge of supply chain, and so that it like I was thinking that it has got some AI steps which actually talk, or your company has got some knowledge about supply chain, so that you provide that information prior to applying the policies. So yeah. Because this is supply chain guard, so because this is when we were talking technology, I have used by the way Prisma Cloud in my career, so that's why I said, how does this different technologically? I think every tool, some does something extra, some does something, right? In every security tools, they do similar things. So because this is chain guard, so I was thinking that, do you have any kind of AI applied to it so that it does specifically better than others in the supply chain?
Yeah, those things I cannot comment yet, but we have some in knowledge stuff about what's going on some programming languages that we can apply the knowledge on those things.
Yeah, some companies, because they have previously, I have seen in my career that some companies, they do have the business knowledge of particular like supply chain. I know a company they had a particular insurance sector. They were a business outsourcing company. So they have a lot of business knowledge. So they created a tool because they have the knowledge of that particular domain. So I was thinking that maybe your company has got a special domain knowledge, so that, and you know how the security works of cloud native. So you combine both to form a company or product called maybe Chainguard, which does specifically special security needs of Chainguard supply chain. I wanted to understand that, what is that? Like, what exactly you do towards supply chain rather than any generic cloud native security tool.
Yeah.
What you said just now, with due respect to you again.
Yeah, no problem. I would say that's
every tool does the same. You apply, you create the policies, you apply the policy, you scan the images, and in the CI/CD pipeline, you obviously, if you apply 2-3 products, every tool does something different, and they are specialized in something. So what is your specialization? By the way, my name is Pansaleshwar. I am from Pure Storage. I work with Adam here. So we are also cloud native company. So we are in the same space.
Yeah.
And
I'm sorry, but there's some stuff I cannot comment yet because it's not like totally public. But I would say if you want to like to learn more, like you can like send us a message and then we can have a more business call properly. Okay. Then we can discuss some internals better with you. Sure. But I would say like we have some knowledge on those things and then we can apply things for you.
Yeah, I'm not asking all the proprietary knowledge, of course, but if I want to like, okay, talk to somebody asked me this question, okay, how it is different than any other tool? So that should be a public knowledge, I believe. How it is different than Prisma, or how are you different than SysDig? How is different than other tools? So some competitive analysis.
Okay. I think that would be a great update for the website. Maybe in the future.
Yeah.
When more questions like this come up, you can put it up on the website, have a comparison metrics or whatever is needed to satisfy the need for answers in that regard. I think Carlos cannot answer them now, so it would just make sense to delay that into maybe a one-on-one, or maybe in the future there will be, I think there will be webcasts and new feature introductions and maybe KubeCon.
Yeah, that's correct. Like KubeCon is there, like there's some stuff we are preparing for KubeCon. Okay. And we're gonna have like soon some videos and more in-depth stuff. For now, there's some stuff I cannot comment. And I would say the thing you can do with the Enforce tool is like, this is just a simple one. You can do much more things that
great. No, I do understand.
You can do that other tools doesn't offer that for you.
No, that's I saw that obviously it's a big tool. A lot of features and functionality was looking like, obviously we didn't have time. I do understand. Anyway, thank you very much for
no problem. Thank you.
Yep.
Okay, probably I have some questions, but I will start with this, I think with a simple one. So we talked about software bill of materials, right? So what are the current standards that are supported? So currently at our company, we're using Cyclone DX. So for generating the SBOM.
Right.
Is there also possible to go into the SPDX?
Yeah, you can use both like Cyclone DX or SPDX. There is no, like in the market, there is no standard on which tool like people gonna use. For example, in Kubernetes, we are using SPDX, and there is a tool for sync. They use SPDX as well, but you can convert to Cyclone DX. But like there's no like a clear definition which tool we should follow. And today, like there's some discussions in the SBOM space with both tools that can be like have some kind of like standards that we can easily compare things, right? Because the problem today in the SBOM is like each company or each tool generate his own SPDX or Cyclone DX. And if I generate one tool, generate SBOM using tool, let's say A, and try to verify that with another tool B, that sometimes doesn't match. But we are like, as a community, we are working to like in towards this, like having like if I generate SPDX with using tool A, if I generate SPDX with a tool B, they should match, right? Yeah. Today is sometimes doesn't match. But
okay,
we're gonna take a little bit of time for that, but I guess we are in the right path.
Yeah, I have then another question. So currently you showed the example with Crow, but Crow is mostly for Golang. So I'm probably not like a Go developer. What tool can I use in combination to build my image and then sign it like in a like in an effortless way mostly?
Yeah, the KO is the, let's say, building the container image for Go applications, but you can use the simple Docker file and use the Docker build to build your container. But to sign is not it's not like dependent on the tool you use to build the containers.
Okay, so it's
we use cosign from SIG Store that used to sign the container image, and cosign also can sign binaries and blobs as well, if you want. And in this demo, we show using the keyless approach that you don't need to manage the keys, like you don't need to rotate stuff, which is sometimes is good. But also, if you want, you can use cosign, for example, with a hardware key. For my personal projects, I have a hardware key that I sign my containers using the UB key. And you can use also KMS, like from any cloud provider, like for example, HashiCorp Vault, to generate the keys for you, and then you can use that to sign.
Oh, nice. That's very cool.
Yeah, we use some tools from SIG Store, like for example, cosign to sign, and we have record and Fusio to generate the keys, and the record to store the transparent logs. That means everything we sign, we push to the logs, and then it's public available. We can match those things.
Cool. That's okay. Then I probably know how we could also integrate it on our side.
Yeah, like let me share again quickly, and then we can see here the pipeline. Let me increase a little bit. This part here, the cosign, is where we sign the image. That is only this line here. You need like sign, and then you pass the in this case which image you want to sign, and that's it.
Okay.
You don't need
to also do it with build.
Yeah, you just replace the previous step where you build your container for your needs, and then you can use this one for your thing.
Yeah, nice. That's cool. Okay, I will be shortly quiet, but I have also other questions left, so no one has other questions.
Go ahead, ask.
Okay, yeah, then regarding I will go back to the SBOM topic. So what would be the optimal flow in terms of generating the SBOM? So would it be best practice in terms of generating the SBOM directly with your source code, then package it into your container, and then it will be signed? Or you do it the other way, generating two SBOMs, so generate first for the source code and then afterwards also for the container, so that I also can catch up the package dependencies from the container if I use like Debian, Alpine, or something like operating system.
Right. Usually I see like people, as you said, you can generate two SBOMs, one for your container and another for your application. And then they can be in different stages on your pipeline. But also, if you are like, let's just talking about like we are generating the container image, right? You build all those things, and then you can use cosign to attach those SBOMs in the container image as well. And then you sign the container image with everything.
Okay.
Or you can sign only the SBOM for my source code. I can sign for my binary, for example, I can sign my SBOM for my container image. But usually like people just attach those things and push together with the container.
Okay, yeah, that's true. So probably also understanding. So are you also now getting more like into more technical way? So with cosign, which current signing methods are currently supported? So crypto signings, because the idea that I have currently behind it. So I work in a company, we do a little bit blockchain, and we have like decentralized identifiers. And they can be stored like on Ethereum, on BTCL, so on the typical Bitcoin blockchain. And mostly what you have there, it's like an identification document, and you have signing keys. But these are mostly not the common known signing curves that you use. They are more like advanced, and if it's probably possible to use them. So because then I can use a distributed PKI, so that goes a little bit more.
I guess you can do, I'm not sure. But if that's not implemented, Science is open source. It's easily to go there and add another option for signing stuff.
Yeah, for cosign.
I can take a look and maybe follow up with you because I'm not sure, like at top of my head, all this stuff.
Yeah, let's try to create. Yeah, but that would be cool.
You can take a look on the github.com/SIG store. I'm gonna post here. There you can see all the certificates and stuff you can use. And with the community is working, like the SIG store right now is in Go, but there is a version in Rust, and the community is also working for a Python library as well.
Oh, okay.
Then as far as I know, there is another person working on the Java also library as well for that.
Oh, cool.
I don't know when they're going to be available, but maybe soon.
Yeah, hopefully. Okay.
Well, time flies. I thought
Yeah,
it was just
and I have not any questions anymore, so I have.
I thought it was just a half an hour. It's 1 hour.
Carlos, thank you so much. When are you going to KubeCon?
Yeah, I'm traveling this Friday.
I should probably go. All right, I'll be in the one in Detroit definitely, but it's been busy on my side, so it's been busy for us. Who else is going on to KubeCon from here?
Sorry?
Who else is going on this list?
I'm going. I'm speaking next Friday about observability, or like from monitoring to observability, left shift your SLOs with chaos. It's more chaos engineering and observability focused, less security. But I'm looking forward to meet Carlos and everyone else.
Awesome.
Yeah, if I have a space, I'm going to speak as well there, but for the SIG release update, it's going to be on Wednesday at midday, I guess. And if you want to hear the updates for SIG release and the release of Kubernetes that we did in the last cycle, for example, signing the containers and generating the bill of materials for Kubernetes, welcome you there.
It's an awesome idea. And there's also the release blog post for 124 explaining exactly what has been adopted with cosign and SIG store.
Yeah. And now just giving like a sneak peek of the talk, the work we did, like signing the Kubernetes releases, now it's available for all the projects under the Kubernetes community. Every project that uses the promotion process, like promoting the image from the staging environment to the production one, is getting signed as well. For example, all the cluster API images for the providers and the cluster API is getting signed. Any other like tool that is generated by the community gonna be signed as well.
That's cool.
Okay. Thanks so much for having me here today. And I'm sorry if my English is not that good. It's not my mother language.
Mine is equally not good too. So that's perfectly fine. We are all technology.
Yeah. And thanks so much. And I hope see you all in KubeCon.
Yeah, thanks so much for joining today and for the awesome introduction demo and answering all the questions we had. We're just saying bye on the recording.
Bye.
Bye.
Thanks, everyone.